In 2024, something extraordinary happened above our planet. Something powerful enough to shake Earth's magnetic shield, disrupt satellite technology, and surprise space scientists around the world. Today, we're going to explore the massive 2024 geomagnetic superstorm that reportedly shrunk Earth's magnetic defenses by almost 80%, and understand what that really means for us, our technology, and our future. Welcome to Space 2 Theories, and if you love scientific explanations in simple language, don't forget to subscribe so you never miss a space update. Let's begin. Part 1. What exactly happened in 2024? In December 2024, the Sun released an unusually strong series of solar flares and coronal mass ejections, also known as CMEs. These are huge bursts of plasma and magnetic fields thrown out from the Sun during high solar activity. When they travel through space and eventually reach Earth, they interact with our planet's magnetic field. This interaction can disturb Earth's magnetosphere, which is basically the invisible magnetic bubble that protects us from harmful solar and cosmic radiation. Usually, Earth's magnetic field repels most of this energy. But in 2024, the energy from the Sun was so intense that our magnetic shield compressed dramatically. Scientists estimate that Earth's magnetosphere temporarily shrunk by up to 80%. That is an enormous change, and it's something that rarely happens on this scale. Part 2. Why did this happen now? The explanation is linked to the solar cycle. The Sun follows an approximately 11-year cycle of increasing and decreasing activity. Around 2024 and 2025, the Sun has been moving towards solar maximum, meaning more sunspots, more flares, and more intense space weather. During this period, large magnetic explosions become more common, and they can trigger geomagnetic storms here on Earth. What made this event special was not just the size, but the speed and direction of the erupting solar energy. Some CMEs were traveling faster than usual, and several of them were directed exactly toward Earth, producing a series of impacts one after another. This combination amplified the storm's effect and compressed Earth's magnetic field far more than typical solar events. Part 3. What does shrinking Earth's magnetic field actually mean? To understand that, imagine Earth surrounded by a protective magnetic bubble. Normally, this bubble stretches tens of thousands of kilometers into space. But when a strong solar storm arrives, that bubble gets pushed inward. Think of pressing your hand against a balloon; it compresses. During the 2024 storm, satellites orbiting Earth detected that the outer boundary of the magnetosphere moved much closer to Earth's surface than usual. This means that more radiation and charged particles were able to come closer to Earth, which can affect satellites, communication systems, and even the upper atmosphere. This didn't mean humans were suddenly exposed to harmful radiation on the ground. Earth's atmosphere still protects us. But the technologies in orbit around Earth were definitely more vulnerable. Part 4. Effects on satellites and communication. One of the most important effects of these storms was on GPS signals, communication satellites, and high-frequency radio signals. When solar storms disturb the magnetosphere and upper atmosphere, signals traveling between satellites and the ground can become unstable. Some effects observed included satellite GPS drift, temporary signal dropouts, changes in ionospheric layers, increased energetic particle impact on satellites. If a severe storm becomes even stronger, it has the potential to cause temporary satellite shutdowns or force operators to switch satellites into safe mode. Part 5. What about the plasmasphere changes mentioned by scientists? The plasmasphere is a region of Earth's upper atmosphere filled with charged particles. During the 2024 event, satellites detected significant movement and changes in this region, almost like waves flowing across Earth's magnetic bubble. Think of it as the inner atmosphere shaking from the storm energy. These changes help scientists understand how Earth responds to extreme space weather, and they are extremely valuable for future prediction models. Part 6. The surprising E-layer effects. Another interesting part of this storm was the impact on what scientists call the sporadic E-layer of the ionosphere. This is a thin layer in the upper atmosphere where charged particles can get trapped. During the storm, the E-layer became unusually active, which led to unusual radio propagation patterns, basically radio signals bouncing in unexpected ways, sometimes traveling much longer distances than usual. For radio hobbyists, this was actually a very exciting time. For communication systems, however, it meant more interference. Part 7. Could this kind of event be dangerous? The short answer is dangerous for technology, not for humans directly. Earth's atmosphere protects us from radiation, but our modern world depends heavily on satellites, power grids, and global communication networks. A much stronger storm could potentially cause global problems like power grid failures, satellite outages, GPS inaccuracy, aviation communication disruption. We have seen this in history. The famous Carrington event of 1859 caused telegraph systems to catch fire. If something similar happened today, the consequences would be much bigger because our world relies strongly on electronics. The 2024 storm was nowhere near Carrington level, but it was one of the strongest storms in recent decades, and a very important reminder that the sun can still surprise us. Part 8. What did scientists learn from this? This event gave researchers important real-time data about how Earth's magnetic field behaves under extreme pressure. They observed magnetosphere compression, ionospheric disturbance, energetic particle increase, plasmasphere changes, and radio layer behavior. All of this helps improve space weather prediction, and that's extremely important for protecting our technology in the future. Part 9. So what's next? Solar maximum is expected around 2025, meaning more solar activity is likely in the coming months and years. Scientists are closely monitoring the sun right now because additional storms or CMEs could happen anytime. We are not in danger physically, but our technology remains vulnerable. Conclusion. The 2024 geomagnetic megastorm was a powerful reminder of how dynamic our sun really is and how important Earth's magnetic field is for protecting our planet. While the magnetosphere did shrink dramatically, this event has also given scientists valuable knowledge and data that will help us prepare for future storms. Space weather is one of the most fascinating areas of science, and as we continue to explore space, understanding the sun becomes even more important. Thank you for watching this video. If you enjoyed this explanation and want more easy-to-understand space science breakdowns, make sure you subscribe to Space 2 Theories and click the bell icon. Your support helps this channel grow and bring more amazing space stories to you. See you in the next episode.